Well, hello and welcome, everybody. I got something I'm pretty excited about right here. This is new for me as of just not that long ago. So let's say that you've got a factor and you can't, and you got to find the x-intercepts and you don't like the quadratic formula. What are you going to do? I've got an alternative for you. This formula right here gives you both of your x-intercepts, works 100% of the time, and I think it's super simple. I'm going to show you where it comes from, show you how to use it in this video. So let's talk about the visuals real quick. If you have a quadratic equation, it makes a parabola, there's a line of symmetry. Right side, left side, exactly the same. Line of symmetry is exactly in the middle. So let's put a dot on it. Let's call it M for midpoint or for middle, right? Now, if we have a horizontal line, the left side and the right side are exactly the same distance. So let's move it to the left, call that P. Let's move it back over and go all the way to the right and call that Q. So the thing we know is that from P to Q, man, M is exactly in the middle. So the distance from M to P, well, the way you'd find that is if you started with M and you subtracted the distance, you end up at P. And the same exact distance going in the other direction would give you Q. So if you started at M and added that distance, you would end up at Q. That's where this formula comes from. So what I'm going to show you how to do is I'm going to show you how to find the values of M and D, plug it in, boom, and you're done. Now this is in the fourth part of our series on quadratic equations. If you're ready for this, go ahead and dive in. If you're just learning and you haven't done all the other stuff, you don't know about the vertex and all that kind of stuff, I'll put links in the description. You can go ahead and grab those videos and get caught up before we dive into this one, because in this one, we're going to be talking about finding the x-intercepts without the quadratic formula, without factoring, completing the square, inverse operations, none of that. All right. Just to make sure we're 100% on the same page. If I had a quadratic equation like this, there's going to be two solutions. They might be real. They might be imaginary. You might not know what that means. It doesn't matter. But you will in the future, and this formula works no matter what. So let's say our two solutions are P0 and Q0, right here and right here. I'm saying that we're going to be able to find them with P is going to be M minus D and Q is M plus D. Super simple. No negative B plus minus square root of B squared minus 4AC all over 2A. That's a monster for a lot of students. Now, M is the midpoint. It's right there in the middle. And D is the distance to either side, right? So let's tuck that away. Let's give our visual representation so that we always know what we're talking about. That's our goal. We have to figure out what M is and what D is so we can find them. All right? So, last thing. If we had something like this, 6x squared minus 7x minus 24. A isn't 1, so what we're going to be doing always is we're just going to divide everything by A. And so what we're going to say is we've got a new B and C. They're both B divided by A and C divided by A, but that's really ugly to type and it gets confusing and there's no need to write it every time. So we're just going to use that over here. We're going to tuck it away and we'll come back to that later. So this is what we're going to write instead, knowing that B is B over A and C is C over A. All right? So couple of things we're going to tackle right here real quick. C is P times Q, and B is negative P plus Q, and I'll show you why right now. All right? Now, if this is factorable, then what you're doing is you're looking for two numbers that multiply to C, P and Q, and add to B, P and Q. Now, maybe you're not convinced yet, so let's take a look at this. Let's say we set it equal to 0. Well, the way that works is you take each factor, set them equal to 0, and solve it. So x equals P, x equals Q. Works that way. And if you took x minus p times x minus q and you multiplied them together, remember the shortcut FOIL, first, outer, inner, last, well, you'd get x squared minus qx minus px plus pq. Oh boy, that doesn't look so good, right? Where does this come from here? I mean, I see that C is P times Q. Well, let's clean this up a little bit. Let's first put it in alphabetical order because that helps. Let's factor out a negative. All right, so we're going to take a negative out. There we go. And let's factor out an x. And look what we've got. Negative P plus Q. So the negative of the quantity of P plus Q is B. So B is right there. It's the coefficient of x like we know. And, of course, C is the constant term. It's the one without an x at all. And it's right there. So let's go ahead and shorten up P times Q as just, P times Q that way. And let's put those on the side over there because we're going to use those later. All right. So we got all our facts over here. Now let's talk about point M. Point M is the midpoint of the segment P to Q. The way you find the midpoint is you add the two ends, divide that by 2. So x1, x2 divided by 2, well, that would be P plus Q divided by 2. All right, that's really similar to what I know B is. B is negative P plus Q. So what if we multiplied both sides by -1? Then we'd get negative B equals P plus Q. Well, I got a P plus Q right there, so I'm going to substitute. I don't know what P and Q are, but I do know what B is, no problem. So I can find the middle just like that, negative B over 2. Now, maybe you recognize that it's really similar to the x of the vertex. In fact, it's exactly the same thing, negative B over 2. Pretty cool, right? All right, now let's work on finding D. So C, we know, is P times Q, and we know P is M minus D, and we know Q is M plus D, right? P is M minus D, that's how we get to here, and the way we get to Q is M, the middle, plus D. So let's go ahead and substitute those things in right there. Since P is M minus D, we're going to put M minus D right here. And since Q is M plus D, we're going to put that right there. Okay, now we're going to multiply. We're going to use our shortcut FOIL, of course. So C is equal to M squared, right, plus DM minus DM minus D squared. Now, dm minus dm, those are the same thing. Well, they're opposites, so you add those together, it makes 0, and you have a difference of squares, m squared minus d squared. So let's solve this for d. Subtract m squared to both sides, multiply everything by -1. There we go. Let's switch those around so we have the negative later. And we're going to take the square root of both sides, and we're done. Look at that. Now let's move the d to the other side because it's just a little cleaner to look at it this way. And now we have a very simple equation. Look at that. So we're saying that the left-hand side intercept is m minus d, and the right-hand side is m plus d. And all you need to know is what the coefficient b and c are. So you would figure this one out first. You just take b, multiply by -1, and divide that by 2. That's your m. That's the first number. And then you take that number, square it, subtract c from it, take the square root. That's d. Then you subtract those two to find one, add those two to find the other, and you're done. Pretty cool, I think. Now, let's try an example. Y equals x squared plus 5x minus 8. All right, that's our stuff right there. So let's start off with m. M is negative b over 2. Now, since b is 5, let's just go ahead and plug that in. There's m. Now, d is the square root of m squared minus c. So m squared minus c. Well, minus c is -8, so that's going to become a positive. Minus -8 is plus 8. Now, m squared, well, that's going to be -5 over 2 squared. So -5 over 2 squared is 25 over 4. So d is going to be the square root of 25 over 4 plus 8. Let's go ahead and get a common denominator. We're going to put a 4. We're going to rewrite 8 in terms of 4, so that's 32 over 4. 32 plus 25, 57. Now the square root of 4 is 2, so we can simplify that a little bit. So we find out that d is just like you see. All right, so p is equal to m minus d, so m minus d. So let's go ahead and put those down here. -5/2 minus square root of 57 over 2. Boom, we're done. Let's do the same thing for q. We know m, we know d. Let's go ahead and plug those things in. We get -5 over 2 plus square root of 57 over 2. That's already got a common denominator. We can just put it together. And if you've already learned the quadratic formula, you recognize it's the same answer. It's just a little quicker to get there. Now, if you're already an expert with the quadratic formula, this might be interesting and cool, and I would suggest you try it because it is really, really simple. For me personally, or other people, that teach math or do math a whole bunch, I've done thousands of examples of the quadratic formula. I think I will always be faster with that than this new thing here. But if you're a student just learning with this kind of thing and you're struggling with the quadratic formula, I think this is a really good thing to do. It's the same end result, and I think it's way simpler, way cleaner. All right. That doesn't mean give up on the quadratic formula, but this is a backup plan. Maybe this is your go-to plan. I think it's pretty cool. Now, what about our ugly one that we started with at the beginning? 6x squared minus 7x minus 24. Let's dive in and tackle that one, okay? All right, so here we go. Let's talk about this one now. Leading coefficient is not 1, so we're going to divide everything by a, which is 6. And we're going to reduce, if we can. right? Negative 24 divided by 6 is negative 4. So let's talk about b. We got to be careful. B is negative, right? Negative b right here. So it's already negative. So the negative of a negative is positive. So negative b is 7/6. C is negative 4. All right. So let's plug that stuff in and find m, and let's find d. So m is half of negative b, right? So I wouldn't write it this way. I would just say, hey, that's negative b divided by 2. That's half of it. So half of 7/6 is 7/12. And now we're going to use that and find d. So 7/12 squared is 49 over 144. So let's plug that in. Okay, minus c. So minus negative 4 would be plus 4. So plus 4. Let's get a common denominator, right? You can use your calculator to do this. You could actually plug this whole thing in if you want. Turns out it's really cool. It's really easy. It ends up being a perfect square divided by a perfect square. Two square numbers, 625 and 144. Take the square root of those, you get 25 over 12. So d is 25 over 12. M is 7/12. So I think this is the most difficult part, but I think that's way simpler than anything in the quadratic formula. So let's go ahead and clean up our screen, put those things over here for reference. Here's our formula right here, the left-hand side, the right-hand side. Here's m, here's d. That's the midpoint. We subtract this distance from the midpoint to get over here. I think that's a pretty cool concept. We add this distance to the midpoint to get here. So starting from the midpoint, you subtract the distance to end up there. Starting from the midpoint, you add the distance to get there. Pretty cool. All right, let's plug them in. So p equals m minus d, so 7/12 minus 25/12. Dang, 18/12. That's, of course, reducible by 6. 3 over 2. Q, well, m plus d, so that's 7/12 plus 25/12, so that's 32/12. Drum roll, please, because that is, again, reducible but to 8/3. Look at that. Man, that's pretty cool. Those two things right there are your x-intercepts. You could do that, or you could do this. It's up to you. They both work. I think it's worth learning them all. I love how this one is a very visual and geometric approach. This one right here has some cool algebra. It's worth knowing as well. I really hope this video is informative, maybe even entertaining. If it was, give me a thumbs up. Let me know how you liked it. And until next time, I hope you have a great day.